At 11:26 in the morning on May 22, 2008, a tornado touches down in a field northeast of Platteville, Colorado. This is already wrong. Not wrong in the sense that it didn't happen. The National Weather Service recorded it, the damage path confirmed it, and 78 people's injuries and one person's death documented it with the specific authority that physical evidence provides. It is wrong in the sense that at 11:26 am on a May morning in Weld County, Colorado. A tornado is not supposed to exist. Not an EF3 tornado. Not a tornado that will travel 39 miles across the Colorado plains. Not a tornado that will become the costliest in Colorado history and the widest and the second longest track, and that will be formally analyzed in a peer-reviewed paper specifically because its behavior was so far outside the regional climatological record that describing it required 4 separate dimensions of anomaly. The tornado touches down. It will not lift for nearly 40 minutes. By the time it does, it will have tracked north-northwest, not northeast, not east, not in any of the directions that every tornado in Colorado's modern recorded history has tracked. And it will have carved through Windsor, Colorado, one of the fastest growing suburbs in northern Colorado, in the most tornado-counted county in the United States. The National Center for Atmospheric Research and the Cooperative Institute for Research in the Atmosphere at Colorado State University spent 2 years studying this tornado before publishing their analysis. The paper they produced, appearing in the American Meteorological Society's journal, Weather and Forecasting, in 2010, characterizes the Windsor tornado as an outlier to the regional severe weather climatology in 4 simultaneous and independent ways. First, intensity. The EF3 rating means winds between 136 and 165 miles per hour. Severe enough to significantly damage or destroy well-constructed homes. The vast majority of Colorado tornadoes are EF0 or EF1. Colorado had recorded only 20 tornadoes of F3 or higher in its entire history since 1950. This was the 20th. Second, track length. At 39 miles, the Windsor tornado had the second longest track of any tornado in Colorado history. Colorado tornadoes are typically short. The landspouts that make up most of the state's tornado count touch down for a few minutes and a few miles before dissipating. A 39-mile track on the Colorado plains is not simply unusual. It is essentially unprecedented in the record of significant events. Third, direction. The tornado tracked north-northwest. This is not just unusual. The RAM case study at Colorado State University, analyzing the Colorado tornado climatological record, describes the Windsor track as the only record of such a direction in the state's tornado history. One event, one northwestward tracking tornado in all of Colorado's documented severe weather history. Fourth, time of day. 11:26 am. Tornadoes in Colorado and the landspouts that are Colorado's typical contribution to the tornado count form in the mid-afternoon to early evening, when the afternoon heating cycle that drives convective development is at its peak. The distribution of significant tornado formation times along the Front Range concentrates between 2 p.m. and 7 p.m. Windsor formed 2.5 hours before the normal window. Any single one of these anomalies would make the Windsor tornado notable in the Colorado severe weather record. All 4 together make it something that atmospheric scientists working the northern Colorado Front Range still cite, a decade and a half later, as the clearest example of the specific risks that non-standard severe weather produces in a population that has been conditioned, reasonably and correctly, for most of its history, to expect something very different. If this kind of deep, real science holds your attention, take a second to like and subscribe. It genuinely helps. Weld County doesn't make sense on its face. Let's begin. Weld County, Colorado is the most tornado-prone county in the United States by reported count. This is not a disputed statistic. It is in the climatological record, and it sounds, to anyone who knows what Colorado weather is supposed to look like, completely implausible. Weld County sits in northeastern Colorado, between the city of Greeley to the east and the Front Range cities of Fort Collins and Loveland to the west. It is dry, flat agricultural territory, wheat, corn, and cattle, bounded on the west by the rising terrain of the Rockies. It is, physically, the eastern edge of the Mountain West, the beginning of the transition from the shortgrass prairie of the Great Plains to the high-altitude terrain of Colorado's interior. It does not, at first glance, look like the kind of county that ranks first in the nation for tornado frequency. The reason it does is landspouts. But the Weld County tornado record also contains, scattered across the decades, the occasional significant event that is not a landspout, a supercell-produced tornado that departs from the county's standard repertoire of weak and brief events. The May 15, 1952 F3 tornado that injured 5 people in Weld County was one such event. It stands in the record as a data point demonstrating that the supercell tornado risk in Weld County is not zero. Between 1952 and 2008, only 20 tornadoes of F3 or higher were recorded in the entire state of Colorado. The Windsor tornado was the 20th in that list, the only one in the modern era to hit a substantially populated suburban community, and the only one in the recorded Colorado history to track northwestward. The 1952 Weld County F3 is the kind of historical event that exists in the record but exerts very little influence on the public's mental model of Colorado tornado risk. Because it occurred more than 50 years before Windsor, when Weld County's population was much smaller, and when no one who was of working age in 2008's emergency management system had any direct experience of it. The experiential memory of significant supercell events in Weld County is, in a practical sense, very short. The last event that a significant fraction of the 2008 population would have direct experience of was Windsor itself, and Windsor was the first major supercell event many of them had ever encountered. This is the context that makes the Windsor tornado more than a local disaster. It is evidence that the full range of Colorado's tornado risk extends beyond what the frequency count and the typical landspout behavior suggest. Weld County's tornado frequency is real, but it is almost entirely composed of weak events. The tail of the distribution, the rare, violent, long-tracked supercell tornado, exists in Colorado's climatological record. It arrived on May 22, 2008. It will arrive again. A landspout is a specific type of tornado. Specifically, a tornado that forms through a mechanism that is fundamentally different from the classic supercell tornado that most people's mental model of the word tornado invokes. In a supercell tornado, the rotating updraft of the supercell thunderstorm develops a mid-level mesocyclone, a large organized circulation extending through the storm, and the tornado descends from that rotation as the circulation intensifies and stretches toward the ground. The classic funnel lowering from a dark rotating wall cloud, the iconic image of severe weather in Kansas and Oklahoma, is the supercell tornado. It forms top-down from the organized rotation of a mature thunderstorm's mesocyclone, and it is powered by the full energy of a supercell's rotating updraft. A landspout develops from the ground up, Convergence lines in the low-level wind field, boundaries where air flowing from different directions comes together and is forced upward, create small, localized areas of rotating updraft near the surface. These rotating updrafts, when they happen to intersect with the base of a developing thunderstorm, can be stretched and intensified into a visible vortex at the surface. The physics is conservation of angular momentum, a small column of slowly rotating air, if compressed horizontally and stretched vertically, must spin faster to conserve its angular momentum. The same principle that makes a figure skater spin faster when she pulls her arms in. In this case, the figure skater is a patch of rotating boundary layer air, and the pulling in is performed by the thunderstorm's updraft. The result is typically a narrow, relatively weak tornado. Most Weld County tornadoes are landspouts rated EF0 or EF1. They are common enough in the specific meteorological environment of the Colorado Plains east of the Front Range that Weld County's count leads the nation, and they are typically weak enough that the county's position at the top of that list does not translate into a proportional share of tornado casualties or economic damage. The convergence lines that produce Colorado landspouts form regularly in the boundary layer east of the Front Range because of the specific terrain-atmosphere interaction of the Rocky Mountains. As the terrain forces air upward on the windward side and allows it to descend on the eastern side, specific patterns of surface wind flow develop in the shadow of the mountains that produce convergence boundaries, narrow lines where surface winds from different directions meet, that are particularly effective at generating landspout formation. These boundaries are a predictable consequence of the Front Range terrain. They produce predictable, routine, weak tornadoes. The Windsor tornado was not a landspout. The distinction is not semantic. A landspout's intensity is limited by its formation mechanism. It grows from the surface upward and depends on the alignment of a surface convergence feature with a developing thunderstorm's updraft. The supercell tornado is powered by the organized mid-level mesocyclone of a mature supercell thunderstorm, a system that can sustain tornado circulations for tens of minutes at intensities that landspouts do not reach. This is why Windsor was remarkable. Not because a tornado hit Windsor. Weld County has tornadoes all the time. Because what hit Windsor on May 22, 2008, was a supercell-produced tornado. Long-tracked, wide, violent, moving in the wrong direction at the wrong time of day. Every dimension of what happened that morning violated the operating assumptions of the local emergency management community, the local media, and the local population that had learned to understand Colorado tornado risk from the Weld County history of primarily weak, short-lived, predictably behaving storms. The gap between that understanding and what actually happened on May 22, 2008 is the specific subject of the research paper that NCR and Colorado State University published 2 years later. But first, the place. Windsor, Colorado in 2008 was not a farm town. It was a suburb, a community of approximately 15,000 people situated between Greeley to the south and Fort Collins to the west, experiencing the rapid residential growth that had characterized northern Colorado through the early 2000s. New subdivisions had been opening in Windsor's eastern and northeastern edges, placing standard American residential construction. Wood frame homes on concrete slabs, often without basements because the Colorado Front Range soil conditions make basement construction expensive, in a zone that, on a day like May 22, 2008, would be in the direct path of a tornado that nobody in the community had any reason to expect. The character of Windsor in 2008 reflects a specific Colorado demographic phenomenon: communities that have grown rapidly to accommodate the economic expansion of the Fort Collins and Greeley metropolitan areas, bringing populations whose relationship with Colorado's severe weather is recent, and who have not necessarily developed the local experiential knowledge that longer-term residents carry. A family that moved to Windsor from Indiana in 2005 brings the severe weather experience base of Indiana, which does experience tornadoes, but whose standard tornado behavior matches the national norm. A family that moved from California in 2007 may have no tornado experience at all. Neither family has the specific Weld County experience that would calibrate them to the distinction between the routine landspout and the rare supercell event. The meteorological science that caused the gap comes first. To understand why the Windsor tornado was anomalous, you first have to understand the baseline against which it was anomalous: the climatological norm for Colorado tornado behavior that decades of observation had established. Most Colorado tornadoes form in the afternoon and early evening. The specific timing window of roughly 2 to 7 p.m. Mountain Time accounts for the large majority of Colorado's tornado events, because the afternoon heating cycle that drives convection in the Colorado environment is primarily a thermal forcing process. The sun heats the surface, the heated air rises, the rising air interacts with the wind shear and moisture available in the atmosphere, and the resulting convective towers, the cumulus clouds that develop into cumulonimbus thunderstorm cells, produce the convergence lines and updraft environments that landspout formation requires. This is a solar-forced process, and it peaks in the afternoon when surface heating is most intense. The timing of the Windsor tornado, 11:26 am, means it formed while the afternoon heating cycle was still ramping up, not at its peak. A tornado forming before noon on the Colorado Plains is not impossible, but it is unusual specifically because the solar forcing that drives most Colorado convective development had not had the opportunity to fully prime the boundary layer. The fact that the Windsor tornado formed before noon is a specific indicator that its parent supercell was not being driven primarily by afternoon surface heating. It was being forced by a mechanism that operated independently of the diurnal cycle. The upper-level pattern and the frontal dynamics that were organizing the May 22 severe weather situation were the primary forcing mechanisms, not the surface heating cycle. This is itself a characteristic that differentiates a synoptically forced supercell event from the typical Colorado landspout event, which is almost entirely boundary layer and surface-driven. The Windsor tornado's timing is not just anomalous on its face. It is a diagnostic signal of the kind of atmospheric forcing that was producing it. A signal that an experienced operational forecaster, looking at the full suite of data available on May 22, would recognize as suggesting a different kind of severe weather event than the standard Colorado afternoon landspout. Most Colorado tornadoes move toward the northeast or east. This is a consequence of the same atmospheric dynamics that govern storm motion across the entire continental United States. Tornadoes are embedded in supercell thunderstorms or in the convective boundaries that produce landspouts, and both are moved across the landscape by the large-scale wind flow that steers weather systems across North America. In Colorado, as across most of the United States, the dominant steering flow in the mid-troposphere carries weather systems from the southwest or west toward the northeast or east. The historical record of Colorado tornado tracks shows this pattern with the consistency that any large dataset shows a dominant statistical tendency. Most Colorado tornadoes are weak. The specific atmospheric environment of the Colorado Plains, the characteristic low moisture, the high elevation, the proximity to the Rocky Mountain terrain that disrupts the low-level wind flow, tends to support weak convective processes rather than the intense supercell development that produces violent tornadoes. The moisture that supercell thunderstorms require is typically not available in abundance in Colorado, where the continental and mountainous environment keeps dew points lower and the dry environment more prevalent than the moist environment that fuels the most intense Great Plains severe weather. This is why the state has recorded fewer than 25 significant tornadoes across its entire history, while Kansas or Oklahoma might experience that many in a single active outbreak day. The Windsor tornado violated all three of these norms simultaneously and by substantial margins on May 22, 2008. The atmospheric setup that May 22 brought to northern Colorado was unusual in ways that a forecaster looking at the morning model data and surface observations would have recognized as different from the standard Colorado severe weather environment. But that a population and emergency management community conditioned to expect landspouts and afternoon storms would not have been anticipating. The Greeley surface observation at the time the tornado was developing showed a dew point of 55 F, not the upper 60s or 70s F that would characterize a Missouri or Oklahoma severe weather setup at its most favorable, but significantly higher than the typical Colorado spring moisture environment. On many Colorado severe weather days, surface dew points in the eastern plains might be in the upper 30s to mid 40s F, dry enough that even with warm temperatures, the atmosphere's instability is modest. A dew point of 55 F, combined with a surface temperature of 70 F, represents an air mass that was considerably more moist than what typically primes Colorado for significant severe weather. The surface-based CAPE, approximately 2,850 joules per kilogram, was modest by the standards of Oklahoma in May, but well above the sub-1,000 J/kg that characterizes routine Colorado convective days. The 0-1 kilometer storm relative helicity of 256 square meters per second squared was in the range that tornado researchers associate with significant tornado potential, in environments where supercells can develop and sustain organized rotation through the lowest levels of the atmosphere, and the lifting condensation level. The height at which a rising air parcel cools to its dew point and condensation begins, forming the visible cloud base, was at only approximately 1 kilometer above ground level. This last number is the most important single meteorological fact about May 22, 2008. The LCL height determines how much distance exists between the cloud base of a developing thunderstorm and the ground below it. Distance through which a developing tornado circulation must maintain its intensity against the friction and disruptive effects of the low-level atmosphere. In the broad scientific literature on tornado climatology, low LCL heights are one of the most consistent discriminators between supercell environments that do and do not produce tornadoes. The physical argument is intuitive. If the cloud base is close to the ground, a developing circulation has less distance to traverse, is exposed to less friction, and finds it easier to reach and maintain contact with the surface. If the cloud base is high, the same circulation must maintain itself through a longer column of the most turbulent atmospheric layer, and has more opportunity to be disrupted before it reaches the ground. Colorado's typical dry environment produces high LCL heights, cloud bases at 2 to 3 kilometers or higher, that tend to suppress tornado formation even in cases where mid-level rotation is present in a supercell. This is one of the specific reasons that Colorado supercells produce fewer tornadoes than comparably organized storms in the Great Plains. The dry air below the storm base creates a hostile environment for developing circulations trying to reach the surface. On May 22, 2008, the anomalously high surface moisture had pushed the LCL down to a height more consistent with the tornado-prone environment of the southern Great Plains. 1 kilometer rather than 2 or 3. This single parameter shift is a critical part of why the May 22 supercell produced a strong, long-tracked tornado, where a similar storm on a drier Colorado day might have produced nothing at the surface, despite having similar rotation aloft. The combination of these factors, higher moisture, sufficient CAPE, low LCL, adequate low-level shear, supported supercell thunderstorm development and tornado formation in an environment where the standard Colorado severe weather mode would not have supported either. And the supercell that developed moved northwest. The direction of motion is the most scientifically remarkable single characteristic of the Windsor tornado, and the one that has the most direct consequences for the societal response analysis that the NCAR paper performed. Tornadoes embedded in supercell thunderstorms move in directions that reflect the combination of the large-scale steering flow and the specific propulsion effects of the supercell's own dynamics. The steering flow is the background atmospheric current at the mid-levels of the troposphere that carries storm systems across the landscape, the same jet stream that moves weather fronts and pressure systems from west to east across North America. The supercell's own dynamics modify this steering in a specific way. The standard right-moving supercell. The dominant supercell mode in the northern hemisphere deviates to the right of the mean environmental wind because the rotating updraft of the mesocyclone generates a pressure perturbation on its right flank that accelerates the storm rightward. This rightward deviation means that a supercell in a westerly or southwesterly flow, the dominant steering pattern across the Great Plains, will typically track toward the northeast or east, a direction that is to the right of the southwesterly or westerly flow. For a supercell to track northwest in a Colorado environment, the atmospheric situation has to be fundamentally different from this standard configuration. Either the large-scale steering flow has to be oriented from the southeast rather than the southwest or west. Pushing storms toward the northwest or the storm's internal dynamics have to produce a deviation that is so anomalous as to be essentially unprecedented. On May 22, 2008, the specific upper-level pattern over the Rocky Mountain region placed the steering currents in a configuration that directed the developing supercell northward and then northwestward rather than toward the northeast. The paper in Weather and Forecasting documents the specific features of the upper-level map that day. The details are in the formal atmospheric analysis. The consequence of those details is visible on the radar, a tornado track moving northwest into Windsor into Larimer County, toward rather than away from the populated Front Range. The RAM case study on the Windsor tornado notes, in its discussion of the tornado's track, that the May 2008 Windsor track still stands out on this map because of its unusual north-northwestward track, as almost all of the other tracks shown on the map were either toward the northeast or the southeast. Furthermore, it is the only record of such a track in the Colorado climate data. One tornado in the recorded history of Colorado severe weather, moving northwest. The consequences of this singular event extend beyond the physical destruction into the specific domain of emergency management and public response, into the story of what happens when an atmospheric event violates the mental model that an entire system of warnings, protocols, and public understanding has been built around. Tornadoes that form on the Colorado Eastern Plains and move east or northeast move away from Windsor, away from Greeley, away from Fort Collins and Loveland. They move toward eastern Colorado and eventually Kansas and Nebraska, toward less populated territory, toward communities that are further from the metropolitan Front Range that anchors northern Colorado's economy and population. This is the mental model that Colorado's severe weather has reinforced for decades. The emergency management protocols, the public communication frameworks, the specific mental models of officials in Weld County and Larimer County about where tornado threats go, all of these were calibrated around a storm that moves away from the populated Front Range corridor. The Windsor tornado moved toward the populated Front Range. It moved northwest into Weld County's most densely populated zone, and then across the county line into Larimer County. It moved toward the communities that storms coming from the east are supposed to threaten, from an origination point that storms were not supposed to originate from. A population that had learned to look northwest to see approaching weather and to look east to watch a tornado move away found itself in a tornado that was approaching from the southeast and heading directly toward the communities to its northwest. The tornado that touched down northeast of Platteville at 11:26 am on May 22, 2008, was visible on radar from its earliest stages. And the National Weather Service Boulder office issued watches and warnings appropriate to the developing situation. The meteorological portion of the warning system performed its function. What the societal portion of the warning system did not fully accommodate was the implication of the northwest track for the communities that lay ahead of the tornado rather than behind it. Tornadoes that form on the Colorado Eastern Plains and move east or northeast move away from Windsor, away from Greeley, away from Fort Collins and Loveland. They move toward eastern Colorado and eventually Kansas and Nebraska, toward less populated territory, toward communities that are further from the metropolitan Front Range that anchors northern Colorado's economy and population. This is the mental model that Colorado's severe weather has reinforced for decades. The emergency management protocols, the public communication frameworks, the mental models of officials in Weld County and Larimer County about where tornado threats go. All of these were calibrated around a storm that moves away from the populated Front Range. The Windsor tornado moved toward the populated Front Range. It moved northwest into Weld County's most densely populated zone and then across the county line into Larimer County. It moved toward the communities that storms coming from the east are supposed to threaten, from an origination point that storms were not supposed to originate from. The NCAR and CSU research paper, published 2 years after the event in Weather and Forecasting, documents specifically what this produced. Some emergency decision makers in Weld and Larimer counties initially processed the warnings through a mental model of where the storm would go that was calibrated on the historical record. That historical record said move east. The storm was moving northwest. The gap between the expected behavior and the actual behavior created a lag in the emergency response, not because the warnings were absent or unclear, but because the warnings described a situation that was difficult to integrate into the established framework for what Colorado's severe weather does. The News Boulder office issued watches and warnings appropriately as the situation developed. The meteorological warning system performed its function. What the NCAR paper found in its analysis of how the warning information propagated through the emergency management system and the public is that the anomalous nature of the storm created specific difficulties in the communication chain. Officials who were accustomed to receiving a tornado warning and mentally mapping it onto the standard framework, moves east, threatens communities to the north and east, had to process a fundamentally different situation in real time. The warnings were accurate. The assumptions that decision makers applied to those accurate warnings were calibrated for a different kind of event. The paper's lead author, Russ Schumacher, framed this as a finding about the gap between detection and societal response. Detection and warnings captivate the meteorological community, but the societal side of the story is equally important: how people receive, interpret, and react to these warnings. Windsor was, in this sense, a predecessor to the behavioral science line of tornado warning research that would be advanced by Joplin and by the subsequent development of impact-based warning protocols. Research that examines not just whether warnings were issued and received, but whether the warnings, in the context of the recipient's mental model, produced the protective action the warning was designed to trigger. The tornado entered Windsor, a town of approximately 15,000 people, in 2008, a growing suburb whose development had accelerated through the early 2000s as the Fort Collins and Greeley metropolitan areas expanded, and the damage survey teams that would assess the aftermath found what the NUVs formally documented as pockets of EF3 damage through the community. The phrasing is precise and revealing. Not uniform EF3 damage. Pockets, the maximum category the rating system assigns to winds between 136 and 165 miles per hour, was concentrated in specific locations rather than consistent across the entire track, which is a reflection of the tornado's variable intensity along its path and the specific vulnerability of the structures it encountered. At the Missile Silo Park campground in the Weld County landscape along the tornado's track, the damage survey documented conditions where heavy trailers and motorhomes were completely rolled, crushed, or shredded by winds that sources describe as exceeding 165 miles per hour. The EF3 category tops out at 165 miles per hour. Winds exceeding 165 miles per hour enter the EF4 category, which corresponds to winds between 166 and 200 miles per hour, and the level of structural destruction that only winds of that speed can produce. The documented description of winds exceeding 165 mph at Missile Silo Park sits precisely at the boundary between EF3 and EF4, not definitively in one category or the other, but providing the basis for the title's observation that the damage in at least this portion of the tornado's track was telling a story about wind speeds at or above the rated category's maximum. This is the specific kind of ambiguity that the enhanced Fujita scale, like its predecessor, produces at the boundaries between categories in terrain where the available damage indicators are limited. A mobile home or travel trailer, while it provides information about the minimum wind speed required to move or destroy it, does not provide the precise structural damage signature that the F-scale's calibrated damage indicators produce from purpose-built structures. The EF3 rating for the Windsor tornado is the correct rating as determined by the available evidence. The damage at specific locations along the path is not inconsistent with winds that bordered on EF4. These two things coexist in the damage survey record. The tornado that entered Windsor proper left a damage path that FEMA ultimately quantified as approximately 850 homes damaged, with nearly 300 significantly damaged or destroyed. Across its 39-mile track, the tornado overturned 15 railroad cars on the Great Western Railway of Colorado, snapped or blew down more than 200 power poles, and left approximately 60,000 people without electricity. At Windsor's main feedlot and at a dairy barn along the track, Approximately 400 cattle were killed by the tornado, or injured beyond recovery and euthanized afterward. Baseball-sized hail. Hail with a diameter of approximately 2.75 inches also fell along the storm's path, adding a second source of damage to a track that was already producing unprecedented tornado destruction. One person died. He was a man at a trailer park near Windsor who attempted to escape the approaching tornado in his motorhome. The motorhome was no protection against winds in the EF3 range. He was killed. His death is documented by the NWs as occurring south of Windsor. In the track of the tornado's most intense phase, 78 other people were injured in the tornado's passage through Weld and Larimer counties. Injuries ranging from broken bones to minor lacerations. Injuries consistent with the violent disruption of a residential and commercial landscape by a tornado that was, for Colorado, without precedent in intensity and without analog in direction. The tornado that entered Windsor proper left a damage path that FEMA ultimately quantified as approximately 850 homes damaged, with nearly 300 significantly damaged or destroyed. Across its 39-mile track, the tornado overturned 15 railroad cars on the Great Western Railway of Colorado. Freight cars weighing tens of thousands of pounds each, displaced from their tracks by the wind pressure and the mechanical disruption of a tornado moving through the rail corridor at EF3 wind speeds. 200 power poles or more were snapped or blown down across the tornado's track, cutting electrical service to approximately 60,000 people across Weld and Larimer counties. In an era of broadband internet and cellular communication, a power outage of this scale also meant the disruption of the communication infrastructure that residents were relying on to track the storm in real time and coordinate their responses. At Windsor's main feedlot and at a dairy barn along the tornado's track, approximately 400 cattle were killed by the tornado or injured beyond recovery and euthanized in the aftermath. The feedlot destruction, the infrastructure of a significant regional agricultural operation physically demolished, represented a loss that extended beyond the immediate economic damage to affect the operations and livelihoods of the agricultural businesses and producers connected to it. Tractor trailers were flipped along U.S. Highway 85, closing the major road corridor through the area and complicating the emergency response logistics that followed. Baseball-sized hail accompanied the storm along portions of its path, adding a second source of damage to structures and crops that had already experienced the tornado's wind. The damage at the Missile Silo Park campground, the location where heavy trailers and motorhomes were completely rolled, crushed, or shredded by winds described as exceeding 165 miles per hour, sits at the specific boundary that the damage said otherwise framing in the title invokes. The EF3 category tops out at 165 miles per hour. Winds exceeding 165 miles per hour are, by definition, in the EF4 range of 166 to 200 miles per hour. A mobile home or travel trailer is not a damage indicator that the enhanced Fujita scale includes in its formal list. The scale uses purpose-built structures with specific engineering characteristics to determine wind speed ranges, and the documentation of winds exceeding 165 mph at this location does not formally change the overall EF3 rating assigned to the tornado based on the broader damage survey. But it does document that at specific points along the tornado's path, the wind speeds were at or above the EF3 upper boundary, and the physical evidence was consistent with EF4 conditions at the location in question. The full damage total, $147 million in privately insured losses, making it the costliest tornado in Colorado history. reflects the convergence of an unusual storm with an increasingly populated suburban landscape. Windsor in 2008 was not a farm town. It was a growing suburb of 15,000 people, attached to the growth corridor between Fort Collins and Greeley that had been expanding rapidly through the 2000s. The residential neighborhoods, the commercial districts, the infrastructure of a functioning suburb. All of these were in the path of a tornado that standard Colorado meteorological expectations had not prepared the population, the builders, or the emergency managers to defend against. The published research on the Windsor tornado produced two specific scientific contributions. The first is the documentation of the meteorological circumstances that created the anomaly. The 2010 paper in Weather and Forecasting examines the atmospheric environment on May 22, 2008, and identifies the specific combination of factors: the anomalously high surface moisture, the low LCL, the CAPE values, the specific upper-level pattern. That allowed a supercell to develop and sustain a violent, long-track tornado in an environment where Colorado's standard severe weather mode would not have supported one. This analysis provides a framework for recognizing, on future days with similar atmospheric signatures, that the standard Colorado assumptions may not apply, that a day with 850 jkg of surface CAPE and a dew point of 55 F and a low LCL height is a day when the standard landspout/afternoon eastward tracking assumptions need to be flagged as potentially inapplicable. The second is the societal response analysis described above, the finding that accurate warnings can be received by a population and decision-making system whose mental model of the event, calibrated on historical experience, may not correctly translate those accurate warnings into appropriate protective action when the event is anomalous in its behavior. Globally, the Windsor tornado provides a specific and well-documented case study for tornado warning and response in mountain-adjacent environments, landscapes that exist wherever a major mountain range sits upwind of a plains region and creates the specific topographic and thermodynamic environment that produces non-standard severe weather. The terrain-influenced tornado environments of Argentina's Sierras de Cordoba, where supercell thunderstorms develop in the orographic lee of the Andes and move in directions governed by the specific Andean influence on the regional wind patterns, share with the Colorado Front Range the characteristic of terrain-induced anomalies in severe weather behavior. The alpine foothill zones of Central Europe, where fen winds and terrain channeling produce localized severe weather events whose behavior may differ from the regional climatological norm, face similar challenges. The zones of complex terrain influenced severe weather in South Africa, Eastern Australia, and the Middle East each have their own version of the same fundamental problem. A population and warning system calibrated to a certain range of severe weather behavior encounters an event that falls outside that range. Windsor is the specific documented case where this problem produced a well-analyzed event with a peer-reviewed paper examining both the meteorological and societal dimensions. It has become a reference point in the literature on mountain-adjacent severe weather climatology precisely because it has documented so thoroughly the NW's damage survey, the published meteorological analysis, the societal response research, and the climatological context analysis all together constitute one of the most complete multidisciplinary analyses of a single tornado event in the literature of a non-standard severe weather region. The Front Range of Colorado specifically is a region where population growth has been accelerating for decades, bringing more people into proximity with the risk that Windsor documented. Windsor itself has continued to grow since 2008, as has Timnath and the corridor between Windsor and Fort Collins. Each new residential development in this corridor is occupied by people who have not necessarily been in the region long enough to develop the historical experience with local severe weather that shapes the mental model, correct for most events, incorrect for the Windsor anomaly, that the societal response research found was partly responsible for the response challenges. The growth of the Front Range population in the years since 2008 has increased the potential consequences of the next Windsor-type event, should one occur, while the distribution of that population continues to include a significant fraction who have not lived through a severe weather event in Colorado and may not have the regional mental model at all, calibrated or otherwise. Windsor's $147 million in damage was a record for Colorado tornado disasters. The 39-mile track was a record. The width up to a mile was a record. The death toll was 1. The injuries were 78. These numbers are smaller than what a comparable storm in Kansas or Oklahoma might produce, in part because the Windsor area is less densely populated than the tornado corridors of the central Great Plains, and in part because the warning system did alert people and some protection was sought. They are not small numbers for Colorado. They are record numbers for Colorado. Every dimension of the damage that Windsor experienced was the worst Colorado had ever recorded from a single tornado event at the time. This comparison, the worst in Colorado history, but modest by the standards of more tornado-prone regions, illuminates the specific risk profile that the Windsor event documents. The Colorado Front Range does not experience the frequency of significant tornado events that Oklahoma or Kansas does. The interval between Windsor-type events may be decades rather than years. But the Front Range's population has been growing during those decades, and the development of residential communities in the arc of terrain between the Rockies and the eastern Colorado plains has been placing more people and more structures in the path of the rare but not impossible supercell event that the Windsor tornado documents. The NDO's warning system for the Front Range region has evolved since 2008. Incorporating the specific lessons of Windsor in its operational protocols and public communication frameworks. The understanding that a northwest tracking supercell is possible, even if it is the only such event in the recorded history of Colorado severe weather, is now part of the operational knowledge base of the forecasters who monitor northern Colorado severe weather. The specific atmospheric signatures that preceded Windsor, the elevated surface moisture, the low LCL, the specific upper-level pattern, are now reference points for forecasting discussions on days with similar atmospheric setup. The research paper that NCAR and CCU published has been cited in subsequent work on non-standard severe weather environments, and has become a reference point for researchers studying tornado climatology in mountain-adjacent regions. What has not changed, and what the societal response analysis suggests is the more fundamental challenge, is the mental model issue. Each year, thousands of new residents move to the northern Colorado Front Range. Each of those residents arrives without the specific experience of having lived through a Colorado severe weather event that shapes the local mental model of what Colorado tornadoes are supposed to do. They may have come from the Great Plains and bring a mental model calibrated to that environment, where tornadoes are common and move predictably east, or from regions with no tornado experience at all. In either case, the specific local knowledge that Colorado tornadoes are weak landspouts that move east is, for most of them, not part of their experience base. When a severe weather event occurs that is unusual for Colorado, they lack the local calibration entirely, which means the gap between the warning and their response may be even larger than the gap the NCAR paper documented in the existing population in 2008. The science knows that another Windsor-type event is possible. Whether it is possible in 2030 or 2060 or 2090, the specific atmospheric physics that produced May 22, 2008 are not prohibited from recurring. The same combination of anomalous moisture intrusion, low LCL, adequate cape and shear, and unusual upper-level configuration will happen again on the northern Colorado Front Range. The EF3 tornado will form again at the wrong time of day, move in the wrong direction, and enter a community whose experience base and emergency management protocols are built around a different kind of event. The question is not whether. It is how many more people will be in the path when it does. The scientific record documents all 4 anomalies. The only northwestward tracking tornado in the Colorado climatological record. The EF3 intensity that is among the 20 most intense tornadoes in the state's history since 1950. The track length that is the second longest ever documented in Colorado. The formation time, 11:26 in the morning. That falls at the early edge of the distribution that Colorado severe weather has established over generations of observation. What makes the Windsor tornado's 4 anomalies collectively more significant than any one of them in isolation is the specific combination they represent. Each individual anomaly, early formation, northwest track, EF3 intensity, long track, is possible in Colorado's climatological framework, given the right atmospheric conditions. Each has appeared, at least partially, in other Colorado severe weather events. But the specific combination of all 4 simultaneously is documented once, and only once, in the Colorado tornado record. The Windsor event is not simply an outlier in one dimension. It is an outlier in 4 dimensions at the same time, which means it represents a specific atmospheric configuration that is extremely rare even within the rare category of anomalous Colorado severe weather. This rarity is both the event's most important characteristic and its most challenging feature for operational warning science. A rare event that violates multiple simultaneous assumptions about how severe weather behaves in a region is, by definition, not the kind of event that the regional warning system, the regional emergency management infrastructure, or the regional population's experiential knowledge is calibrated to handle. The warning system was designed for the normal distribution of events. Windsor was so far in the tail of that distribution that the normal system's performance, which was technically competent, produced an imperfect societal response in ways that the 2010 paper documented, and that the research community has been working to address ever since. The community of Windsor rebuilt. The feedlot was eventually rebuilt. The railroad track resumed normal operation. The power poles were replaced. The 850 damaged homes were repaired or rebuilt over the years following May 22, 2008. The EF3 rating remains. The Northwest track remains in the record as the only occurrence of its kind. The morning formation time remains a data point in the distribution. The paper in Weather and Forecasting has been cited in subsequent work on non-standard severe weather environments, and on the gap between warning systems and societal response to anomalous events. The man who tried to escape in his motorhome does not remain. At 11:26 am on May 22, 2008, a tornado that Colorado's entire recorded severe weather history had not prepared anyone for touchdown in a field northeast of Platteville, and began moving northwest. It moved northwest for 39 miles. It was the widest tornado Colorado had ever recorded. It was the costliest tornado Colorado had ever recorded. It killed one person and injured 78 others and left a community rebuilding for years. It was the only time. The atmospheric physics that produced it are not prohibited from recurring. The specific combination of anomalous moisture, low LCL height, adequate shear, and unusual upper-level pattern will happen again over the northern Colorado Front Range. When it does, the EF3 tornado will form again at the wrong time of day, move in the wrong direction, and enter a community whose population has grown larger than it was in 2008, and whose residents include thousands of people who moved to northern Colorado after May 22, 2008. And have no direct experience of what the day produced. It was, by every available metric, something that Colorado's tornado record said should not exist. It was the only time. The question is not whether there will be a next time. The question is what the next one finds when it arrives.